Okay, I hope everyone can hear me. If you cannot, please let me know. Okay, cool. Thank you. I see some messages coming in. All right, cool. So let's start the recording of the webinar. So welcome again to the Factory Utilities 101 Part 2. In this webinar, we're going to be discussing the factory utilities, and we'll be taking over from our last session, which was Part 1. Just a quick summary of what you can expect to see. So we've got the agenda very quickly, a summary of factory utilities. We're going to recap from our last webinar. We're going to take a look at the factory utilities, where it is, what's available. And the demo for today is going to be based on a substation design. Now, with the substation design, you find that you can actually create quite a bit of equipment in the asset browser, asset plane. You author them for the factory utilities or the factory assets, and you actually bring them into your 2D layout, synchronize with Inventor, and you make them 3D. Now, this data can be used greatly downstream with regards to doing process analysis of it, also renders, take it into Navisworks for clash detection, or looking at project timeliners. We highlight here the ease of use, in a sense that you can actually use this data from AutoCAD all the way downstream to actually do checks on the model, as well as high quality renders. Following that, we'll do a question and answer session, and we'll have the questions going on from there. Okay. So moving along, just a summary of it. So Autodesk has great workflows when it comes to the factory environments between multiple applications. Obvious course being one being a process analysis tool, or Process Analysis 360, which allows us to go in and analyze the results of our layout. Okay, and we can see what maximum time frames, if there's any costs, how much of output can we expect from the equipment that's being produced. AutoCAD and Inventor and Navisworks are great workflows. In this webinar, we can explore some of these best practices. However, we're going to focus a lot on the design itself. The previous webinar that we've done, Part 1, looked at actually authoring components for the factory utilities, as well as creating factory assets that you can use to be processed in the process analysis tool. Okay, so let's move along. Just a recap from the last session. So with the factory utilities, it is available in the product design and manufacturing collection. And with that, you have tools like AutoCAD Architecture, tools like AutoCAD Mechanical for your 2D layouts. Following that, you would use Inventor Professional for this to synchronize with AutoCAD using the factory utilities tabs. And from there, you could take that into a process environment, do process analysis, and work with it from there. Okay. This can be used, of course, downstream with programs like Navisworks, where Navisworks allows you to do a visualization of your components. If there's any clashes or any clash detection needs to be detected, you can actually detect it using Navisworks, as well as a lot of fly-throughs and walkthroughs as well as a render. Also renders, sorry. So if we move on, we find that here's a typical example of what a factory layout will look like once it's been rendered, and you can see it is quite comprehensive. Just recapping from the last time where we discussed this in further detail, as you can see, it is quite comprehensive in the sense that you can see all of the components going into it, conveyors, equipment that's being processed through as well. And where does it fit in with the whole Industry 4.0? Now we find that it combines a wide variety of tools, technologies becoming well known. And if we look at it, it sits more or less in the product design and process environment, where a lot of virtual installations are taking place nowadays. A lot of scanned equipment's coming in. used in greenfield, brownfield projects. So it's the first stages of the Industry 4.0 sector. If we look at project-wise, there's greenfield projects that you can work with. So complete new layouts, bringing that in from 2D and synchronizing to 3D and back and forth, which gives us great visualizations, as well as taking it into, of course, the scanning environment, where we actually bring in scan data that's existing. But for greenfield projects, it'll be more new layouts. So all the new layouts that's being created, that could be taken across into Navisworks, for instance, to do clash detections, to actually see where there's issues before the building or the equipment's actually placed. If you look at brownfield projects, again, as mentioned, scanning is becoming quite popular nowadays. We find that there's a lot of scan data in the form of point clouds that's being produced. People are scanning a lot more. It's a lot easier. It's a lot more accurate to work that way. And if you bring in scan data, you can bring it in one of the applications via reality capture or recap. Bring that into the factory utilities, and you can have your equipment laid out around it. So for brownfield projects, it works very, very nice, and it's quite popular in that sense. So it's really an asset to have if you're doing these type of projects. Now, moving along, you find that the process analysis tool itself allows you to actually, it's twofold, right? So inside of AutoCAD Mechanical, you've got the analysis tools that you can do to actually look at travel costs between the components and time that's taken to it. That can be, of course, quantified into a cost, which you can actually see how much of it costs to actually run the process from end to end, or how much of time does it take for equipment to move across. More to the right is a snapshot of the process analysis that has been set up, and you can see that there's stages that it works off, different type of processing equipment like CNC lathes. You can have different types of cutting equipment, processing equipment that go in there, and once that is set up, you can simulate the time between all of the components to actually give you an end result of how long it would take to produce or manufacture a component. If you move these assets around, you'll find that you could either decrease time or increase time based on selections made, and you can optimize this layout digitally before it's actually done. So it adds quite a bit of value to layouts that you're doing, and also allows you to predict where you can optimize your factory layout. Now let's jump on to the demo itself. We're going to talk about, in this demo, we're going to speak about this process that we're going to set up here. And it is based on a substation design. What you can see is the 2D layout inside of AutoCAD. And if we look at it, this is a substation that's going to be it's just 2D laid out. We're going to start it up, and we're going to place in, we can XREF the components in. And what we're going to do is we're going to bring in the new station, or the new area that we're going to actually lay out our substation in from the overall building. Now, using XREFs is actually a really great method, or great way to do it, because it allows us to work with the XREF itself inside of AutoCAD. Okay, so if we look at just the XREF area that we're working with, now in here, we're going to come in and we're going to go into our factory environment asset browser, and we're going to place in some assets that we've created. Now these are user assets created, and what these assets are, they're basically custom assets that's being created. We're going to jump between custom assets as well as the ones that are standard. As you can see, the security fence that we're putting in, that's a standard asset that is available with factory utilities. User assets can be created by yourself using Inventor and published in. So it's a very, very comprehensive tool. So if you're quite familiar with working with Inventor, this will be a very easy task to do. Okay, so we're going to place in some of the assets. So a low voltage asset that's placing, so substation design. Okay, and we're going to place in a couple of more assets from our user assets in here. But before that, we synchronize with Inventor. We've got to save the components. We've got to save it in AutoCAD. And notice what happens when you do it in Inventor. It synchronizes from a 2D model to a 3D model. Our security gate that we put in has come across, as well as our assets that we've created that is coming across. Now, this is an assembly that has been simplified. Best practice here is to simplify before you bring it across, because it's just translation time is a lot better. We can resize our landing space or our floor to suit, and we could go in and add more configurations. Now let's take a look at the security fence. It's all closed up. Because this is a asset that's been created using Inventor, it keeps the parameters that's linked to it. So we can modify parameters directly inside of Inventor from the factory properties tool. And once that's modified, we just got to update it, and it updates, as you see there. So going back into Inventor, we can drop in, back to factory assets, we can drop in more assets. Now, you'll find that when an asset is authored, there's connection points that's allocated to them, which you would allocate, and that allows you to actually snap assets as you're placing them in. So it makes assembly a lot easier. Again, modifying the parameters that's linked to it, so make it a bit smaller to 1500 mils, and as soon as you update, it updates to the size that you've selected. So it's pretty intelligent. It's pretty nice to work with. And as you can see, it's not we're using some iLogic rules here, so true and false rules that's been given to it, and we're just going to update that, and we can see that it closes up. Now, if we go back into it, we go into our standard assets that's available to us. We're going to go and drop in some signage. Now, you can use the snaps that's available, snap to surface, and this allows us to actually snap our signage on. It could be a warning sign, it could be like as we see in here, this is a warning sign that goes in. It just adds a better feel to the model itself. We can assemble it, so using constraints again, we can use a mate constraint on the side there just to mate and flush it, and we can pick up the face so we know where it's going to be constrained to. Add a bit of an offset. We bring that in. Okay, so again, modifying our parameters, we can change the parameters directly from the properties toolbar. We can add in more equipment. Now, this could be done in the 2D environment as well. However, for the purpose of this exercise, I just want to show you how the snaps work and how easy it is to change parameters in 3D. So we've changed the size of that pylon. We're going to actually drop in a couple of more equipment. So it's a base plate that's going to go there. And as you can see, it was defined with snaps. Whenever you bring it in, you can snap it. Now, on the left-hand side, you'll notice that there's some numbers linked showing next to each asset. This allows us to actually change sizes. Those are parameter sizes that's linked. As you can see, we modify that from 2 to 3, and we can extend it. So it's really, really easy to work with. All of these snaps allow us to assemble quite quickly, making the assembly actually quite easy for us to work with. Now, also members, we can actually snap them across because they are intelligent. As you can see there, it actually snaps the size of the member it's connecting to. Save that, synchronize it back to AutoCAD to actually do some changes in the 2D environment. So we'll just wait for the model to synchronize. And we get a message saying that we should open it up in AutoCAD. And as you can see in AutoCAD, the component that we dropped in inside of our Inventor 2D model, it actually shows in. It's a lot easier to manipulate where the geometry is placed. inside of AutoCAD because it's 2D based. So processing power is processing time actually is a lot quicker. We can do an array of these assets that we've got in here, which allows us to actually array components a lot quicker when it's done in the 2D layout versus the 3D layout. So it's just good practice doing it that way. So we have an array done for components. I'm going to remove that bit and the top bits that's sitting outside of the boundary conditions that we've specified. If we go in, we can move that and position it closer to where we need to have it. Again, we've seen how we've placed assets in the 3D environment. Let's place some in 2D. And as you can see, we can drop in various assets in here. Okay, now, which is very nice because again, we can also array them, copy them, as well as move them inside of the 2D environment. Okay, we're gonna go and do an array again. So how many rows do we need? We'll choose 3 this time, and it's going to be 1 column, right? We can specify offsets in here. We can specify row offsets, array offsets, select our objects, and also array them. Okay, synchronize back with Inventor. We prompted to save it, and it opens up in Inventor. And as you can see, the components are being synchronized from 2D onto 3D. So the assets that we arrayed inside of the 2D environment in AutoCAD, that has come across, it's translated into Inventor. And as you can see in there, all of the components coming in have been placed in the areas that we need them to be. And we've got our basic layout of our substation. So we're going to change some sizes here, update that so it is much higher. Okay, it's got some of the assets have iLogic linked to them, as mentioned earlier on. However, some of them do have the parameters linked to them, which can be modified. Now, inside of Inventor, as you can see, we use the cable and harness, and we just drop the cable from one point to the other, showing that there is some connections. We're going to synchronize back to AutoCAD now. To see what it looks like in the 2D environment. And as you can see, our cable and harness that we put in have come in. We save that in there. We're going to go back to our main drawing where we had the XREF in, reload the XREF, and you can see the components that we've placed in there does come back in. If we jump back into Inventor, we're going to suppress some of the features in this. We don't want to see that. Okay, and notice what happens now if we go in and modify the pylon bit, the structure bit of it. We can just placing in from our asset library. Notice that it also snaps to the sizes that the pylon is, and because we've got snap selected or snap set up connection points, it allows us to just connect to each other, which is really, really nice, especially when it comes to assembling. It's much quicker, and the time that we take to assemble is a lot. The effort that we use to assemble is a lot easier. It's a lot less effort. Okay, so we're going to add some more structural members to that. We can put this into a drawing directly from here, and just place that in. Place our views. Set our scales. See standard Inventor. Just to make it slightly smaller so it fits nicely on the page. Bring in various views and an isometric. We could also pull out things like bill of materials all out of here as well. Different types of Inventor shading views or wireframe. Standard Inventor functions. Zoom in, it looks like our model. We can go back into the model, drop parts list in. So we can choose our bill of materials, parts only, and place that down there. Okay, you can see it is slightly on the way. Let's drop the scale down. That's a lot better. Move the model into position. And yeah, that's our substation. So very easy, very quick to do. We're going to go into cable and harness now. We're going to drop in some cable connecting from different areas. So we're going to go in and choose the cable, the wire that we're going to create, choose the points, drop in cable, apply that. So it gives us a good indication of what's going on because these are live components that we're working with. So we could actually see what's happening in here. If we look at the cable that's there, we can go in and add connection points to that. So we add a point to that cable there to connect them up. Okay, so we can allow for it to sag a bit if we need, or if it's connecting to another component in our substation design, we can allow it to connect. So just by adding points and connecting the 2 points together. Add one more point to that and redefine it. There we go. So we've got our 3 cables placed already in there. You can finish the cable harness now. Go back into the model and you can see it's active. Let's switch off these work points axis and some sketches so we don't see the work features inside of our assembly. Bring it back and you can see where the cables are connected. Now if we go back into the model, just do an update in here, notice that it has come in. Okay, the parts list has also updated a bit, so we've got to move that into position. And if we go back into the model, let's see, floor size, do we make it visible, invisible? We've got options in here. We could actually go in and do some setups on the floor to actually see if we want to take the grid off or just have it a solid plain floor. Change the appearance of the viewing, the way we view it, either perspective or orthographic, and also reflection. So we can set this up for rendering. If we had to render, so with rendering, you could use Fusion 360 to actually do the renders with the render environment inside of that, or other rendering tools. And this is what it looks like once it's rendered. Of course, we can change environments and orbit it around to actually show it off. If we use a tool like Fusion or something like Navisworks, we could actually go in and create videos out of this render that we've created. So that was just an overview of what can be created using the factory utilities. It's a very, very nice tool that we can work with. And as you've seen, it's very easy to actually go in and create once we've have assets that's been authored, which are customized assets or user assets. However, using standard assets, as you've seen, is pretty easy to work with and pretty easy to manipulate as well with parameters. You can have iLogic linked to that. You could have using normal standard parameters as well linked to that, have them update in different sizes so you can control the sizes of them as well as where they snap to each other. Okay, just in conclusion, simple and easy ways to create just more than factory layouts. you could see that it's quite straightforward. It's quite easy to actually work with it, placing them in the 2D environment or inside of Inventor. It allows you to actually manipulate these assets quite nicely. The workflow between the 2D and 3D, so workflow between AutoCAD and Inventor is simply by a click. So synchronize to Inventor or synchronize from Inventor to AutoCAD. It's just a click away. Once you click it, the application does all of the work, synchronizes in the background, and opens up inside of AutoCAD or Inventor. And it's a seamless workflow, right? So if you've got assets created for Inventor, those assets are published. When they publish, a 2D variant of that asset is created, and that allows you to use them inside of the layout environment or the 2D environment for AutoCAD, as well as use them inside of the 3D environment for Inventor. So it's actually a really, really nice workflow. Next, we're going to take some questions. So if there's any questions that you have, please type it out on the chat box, or raise your hand, and we can go ahead and answer them. I'm going to leave some time open for questions, so please feel free. Oh, Jeff, thank you for the question. Is there any special ways to program the iLogic for it to be used in factory? No, so it's using standard iLogic techniques. So if you've got let's say, for instance, if it's a size change that you need to manipulate, you do your setup inside of Inventor. So all of your iLogic code, you can create a form as well to manipulate that, to check what's happening with it and how is it working. If it's tested and works well inside of Inventor with the iLogic and all the parameters are working, when you do the publish to factory, you've got to indicate that there's parameters that needs to come across for you to change. So asset variance. So you've got a asset variant dialog box that comes up as soon as you publish it, and in there you'll specify the variance. So what it does is it will read all of the iLogic that you set up across into the factory utility.